3. We are doing rotations today, and I'm going to show you. Yes, sir?
So if reflections was a capital R, then what is rotations?
Oh, I'm going to get there in just a minute. With rotations, do you know another, like the layman's term for a rotation? A turn, right? We're doing a turn. The thing to notice about a rotation is it will have the same orientation as the figure it started as, okay? So remember, reflection had opposite orientation. If we named the one clockwise, then the reflection you would name counterclockwise. God bless you. With a rotation, you'll name them both clockwise or you'll name them both counterclockwise. It's not one of each anymore. So they do preserve distance and angle measure and orientation. It is going to be a rigid motion when we do a rotation. So I just want to show you real quick the setup, what this might look like. And if you don't draw it exactly like mine, that's okay. But I want you to see the relationship between these. Can you not throw the ball right now? That'd be great. That's not good. Try again. Let's do this. If we're going to rotate this point, okay, the way it works is there will be what's called an angle of rotation. So let's say my angle is going to be this angle here, okay? This is called the angle of rotation. And then you will take that figure and rotate it so it now looks something like that, we'll say. When you do a rotation, every point that you rotate rotates the same amount, the same number of degrees. So this angle right here would have to be the same. Let's say I connected these points now, right? That angle is also going to be X degrees. I'm going to take that away just so you can not get confused with all the overlap. But there's always going to be this one angle that you're going to keep throughout the whole problem, okay? When you write a rotation, this is what Daniel was just asking. So we did translation was a capital T, reflection was a capital R. Rotation has an issue because it's still an R, but we already used a capital R, so we're going to go lowercase r, okay? So when we say a rotation, we will say what we are rotating around. I'm going to call this point P for right now, just so you can see in my setup here what we're going to do. You're going to say a rotation of X degrees around whatever point you're rotating around for whatever figure you're rotating. So let's say it's triangle ABC, okay? Lowercase r is rotation. X is how many degrees. P is the point that you're going to rotate around, okay? So I'm going to do a rotation for you right now. One thing to note, when you do a rotation, if you look at this picture, this distance has to be the same as that distance. It has to be the same distance away from the point of rotation at all times, okay? So I'm going to do one for you. If you have a protractor and compass, get it out if you would like to borrow one of mine. Okay, so when you do rotations in the coordinate plane, instead of this, right, this is, you're actually drawing a picture of a rotation. With coordinate plane, it's a little bit different. You do more calculations than anything. I will never make you memorize these. So please don't spend time trying to memorize them. Just have your notes in front of you while you do the homework. If we put it on a quiz or a test, we give you the formula for it, okay? So for rotations in the coordinate plane, you will have this. If you do a rotation of 90 degrees around the origin, okay, so O for origin, of some point, okay, point XY, what happens is that point, when you rotate it 90 degrees, becomes the opposite of your Y value followed by your X value. So it takes those values, flips where they are in the setup, and makes the first one negative now, okay? If you do a rotation of 180 degrees around the origin in the coordinate plane, this one's probably the easiest one to remember. You just take the opposite of both your numbers. So negative x and negative y will be your setup with that one. And then the last one, if you do a rotation of 270 degrees, which really would be a clockwise rotation of 90, if you want to think of it that way, this becomes your y value first, and then the opposite of your x value, okay? So I'm just going to show you that. We're not going to do a ton with this right now, but I do want you just to see where this is coming from. So you have the point 4, 2. 1, 2, 3, 4, 1, 2. Okay, this is our point G. Let's say we want to do a rotation of 90 degrees around the origin for that point. Okay, so right now my point is 4, 2. If we rotated that 90 degrees, where would I end up if we follow that rule above it? Negative 2, 4. Okay, so negative 2, 1, 2, 3, 4 would put us right here. And you can see that if you draw the lines in, right, we went 90 degrees counterclockwise. That's your rotation. You with me, Adam?
No.
I'm far more interesting than he is.
100% not into
All right, this one, if we rotate that same point, our same G, now we rotate it 180 degrees instead, so we're still taking the 4, 2. What's it going to become? Negative 4, negative 2. So if we rotate that, negative 4, negative 2, we'll call this G double prime for now. Again, look at what you have. A straight line, right? 180 degrees would get you over there. Okay? Last one, if you took that 4, 2 and you rotated it 270 degrees, where would you end up? 2, negative 4, right? So we take our y value and then the opposite of our x value. So 2, negative 4. 1, 2, 1, 2, 3, 4. That makes this angle 270 degrees. Okay, so it'll always be the same numbers, just in different places or as opposites of what they were. Okay, but like I said, I will always give you the formula for this if we ask you a question like this. Okay, any questions on that? Okay, then last thing. This last one I would say is the one that probably gets done clockwise more than any other problem that I give you with this. If you have a regular hexagon, what's a regular hexagon? 6 sides, all the what? Sides and angles are congruent, right? So we're going to say this is a regular hexagon, okay? And we are rotating around point X and asking this question: what is the angle of rotation from point B to point F? Okay, and here's what you have. You have A, B, C, D, E, and F. Okay, now this one's going to say don't use your protractor, it's not drawn to scale. So you can't just measure what you want to measure here. But we're going to be rotating around this point right in the center. So if we're rotating around that point and we're starting at B and we're going to F, first of all, what direction are you going?
Right. I mean, counterclockwise.
Counterclockwise, right? We want to go this way. So we're working our way around to here. So essentially the question they're asking you is, what is this angle? Okay. It's actually not.
It's like
Oh, you know what? It is.
It is.
130.
It is. You have a kite
Degrees.
going on, a diamond going on there.
130
Huh,
degrees.
I've never looked at it like that before. How many?
103.
No.
102.
So if you look at this setup, okay, we cannot just measure it with a protractor, but look at what we have. If I draw every one of these angles in, okay, what is going to be true of all 6 of these angles? They're the same because it's a regular polygon, okay? So if those are all the same, I can figure out what one of them is by doing what?
360 divided by 6.
360, because it's making a circle there, right? 360 divided by how many angles we have. We have 6 in this one. So 360 divided by 6 is 60 degrees. That means every one of these angles is 60 degrees all the way around.
120.
Okay? So to go from B to F, right here, we have 2 of those angles. So you're going to take the 60 and multiply by 2, which would be a 120 degree rotation. Okay, so if I wanted B to land perfectly on F, you would have to rotate that figure 120 degrees.
Is this Fahrenheit or Celsius?
Neither. Nice
I can't
question.
remember.
Any questions on that? Yeah.
What if they weren't split into triangles?
Well, they won't be. Like I drew the triangles in for you, right? But it
No,
will
but
always
like-
be a regular polygon
But
that
like,
you're.
what if you split it and they weren't equal triangles?
We won't ever give you one that isn't equal triangles because you wouldn't have a way to calculate that with what we know how to do. Yeah, it'll always be a regular polygon. So, good? Okay. I